All right, let's go over 1152, analyze user website visit pattern. So they give us three arrays here. They give us some usernames, they give us some timestamps, and some websites. This just represents which user visited which website at what time. And these three arrays here are going to be the same length. Okay, so let's just go through some examples. So first of all, they define a pattern. They define a pattern as a list of three websites that are visited in that order by some user, or at least one user. So for example, let's say I have these usernames here. So I have Casey 3 times, then Sasuke 3 times, and then Lelouch 3 times. And Casey visited LeetCode, then he visited LeetCode again, and then he visited LeetCode a third time. And then we're going to say Sasuke visited the Hidden. He visited this website called Hidden, then Sasuke visited this website called Leaf, and then Sasuke visited this website called Village, and so on. Like Lelouch would have visited LeetCode 3 times in that order. So our patterns here, we actually have two patterns. So one pattern is LeetCode, because Casey visited LeetCode in this order 3 times, and Lelouch also visited LeetCode in this order. So this is going to have a score of 2 because there are 2 users that visited these websites in this pattern or in this order. So and then the second pattern would be Sasuke visiting Hidden, Leaf, and Village. So that would be pattern number 2, but it would only have a score of 1 because Sasuke was the only one to visit the websites in that pattern or in that order. Okay, so, and then one other thing I want to make clear. So in this next example, let's say Casey, I just have Casey here 6 times. Now let's say Casey visited LeetCode 6 times. Well, this only has a score of 1. So think of the pattern as a set of users that followed this pattern. So for example, our set here would just be Casey. Just because I visited it like 4, 5, 6, or 1,000,000 times, I don't just keep adding myself to this set and incrementing the score that number of times. So it's just so just think of it as like a set. So I can only add myself once to one pattern. Okay, so and the last thing I want to make clear in this last example, let's say I have Casey 4 times. What I want to make clear is that we don't have to visit the websites back to back. So for example, say I have LeetCode, I visited LeetCode, YouTube, then LeetCode, and LeetCode again. So notice that I have this YouTube in the second slot, right? So some patterns here could be LeetCode, YouTube, LeetCode. So I have that pattern here, LeetCode, YouTube, LeetCode. And another pattern could be LeetCode, LeetCode, LeetCode. So I have that pattern here. Notice that I was able to skip YouTube. So when I say a sequence, I mean, the only thing that matters is the relative ordering that I visited the websites in, but I'm allowed to say skip websites when I'm creating these patterns here. Okay. And then one last pattern would be, say, YouTube, LeetCode, and LeetCode. So those would be the 3 patterns if I were given this as my sites and this is my usernames. Okay, so now let's actually figure out how we're going to do this. So let's just comment all this out and just go up here. All right, so let's code this out. First thing we're going to do is we're going to map all the users to all the websites that they visited at what time. So let's create a map of users to a list of pairs of their timestamps and the website that they visited, the name of the website. Okay, and I feel like I'm missing a bracket there. Okay, so we'll just call this users map, new hash map. And we're going to loop through. Doesn't matter which array we pick because they're all the same length. And we're going to let me just copy paste one of these. Okay, cool. And we're gonna create a list and map it to the username in this hash map here. So let's do, what do I want to call this? Visits equals usersmap.compute if absent, and we're going to pass in the username, and we'll create the array list if that key doesn't exist. So if this key doesn't exist, we're going to insert it. So if this key doesn't exist, we'll insert this array list, and then compute if absent will return the array list that we created. But if the key does exist, it'll just return the array list that we created in a previous iteration. Okay, and then what we can do is visits.add the pair. So this will be the timestamp and the website. And the reason we're doing this is because we're going to be able to sort every user's visits by their timestamps, which will be useful later. So now let's actually loop through every user's visitations. So let's just do this for every map.entry. I think I'm going to just copy paste this guy right here. Yeah, that'll work. So map.entry, we'll just call this entry in our user's map. And let's create some variables. We'll just say user equals entry.get key. So this user here will just be the username that we stored right here as a key. Okay, and let's just copy paste this guy right here. Okay, and the visits is just going to be entry.get value. Okay, so now we have the visits, and then we're going to sort those visits. So let's just do collections.sort, pass in the visits, and collections.sort doesn't actually know how to sort our list of pairs. So what I'm going to do is create a comparator. So let's do A, comma B, and we'll do a.get key. So this is a pair here. So we're getting the timestamp, and we're going to subtract it by B's timestamp. So all this is doing is just putting it in ascending order by the timestamp. Okay. And now what? We want to create all the different patterns, or all the different sequences of patterns of 3 for every user. So right now we're going through every user, right? Because oh wait, this needs to be entry set. Okay, so we're grabbing a user, and now we need to go through all of that user's visits. So, and now the visits are sorted because we sorted it here. And now we're going to create all the different patterns for this user's visits, for this user's website visits. Okay, so we're going to do I equals 0. We're going to do like a triple for loop thing to create all the combinations. So I is less than visits dot length, or no, sorry, dot size plus I, and this will actually be, you know what, let me do it at the end so we could just, I'll just keep going. So we're going to do like a triple for loop because we want all the combinations of 3. So let's just make this I, j, and k. So j is going to equal I plus 1, k is going to equal j plus 1. And we're going to do j is less than visits.size, k is less than visits.size, and this needs to be j and this needs to be k. Okay, and this I equals 0 actually needs to stop 2 short of the end. This one needs to stop 1 short of the end because we're doing I plus 1 here and j plus 1. So, and we just want, so this I would be like would stop at the third to last item, and this would stop at like the second to last item here, and then this would stop at the last item in visits dot size. Okay, so did I wait? Why is okay? Never mind. So now what we're gonna do is we need to keep track of which pattern has the greatest score. So we have to do a little bit of bookkeeping here. So we're going to create a map of, so this string here is going to represent our pattern of, say, 3 websites. And we're going to map those 3 websites to the set of users that visited those websites, like in that pattern. So we'll call this, what do I want to call this? Pattern to users map. I think that's a good name. Equals new hash map. Okay. And here we're going to create the pattern. So let's just say string, we'll just call it pattern equals visits.get I, and then, oh, sorry. So this visits is going to return a pair, right? Or sorry, this visits get I will return a pair. So we need to get the value, because the value in the pair, because we map the pair is holding our timestamp and our website. So this get value is actually the website name here. So and then we need to do this for, so we're going to create a little delimiter here. You could pick a star, a colon, a money sign. Either one works, because all the websites are using lowercase English letters. So I'll do visits.get j.get value plus colon, and then, oh, this actually needs a plus here. Okay, and then visits dot get k dot get value plus colon. Oh wait, we don't need a delimiter there. Okay, cool. So all I'm doing here is I'm going through all the possible patterns, and now what I want to do is check if this pattern, or we want to add this user, or we want to map this pattern to our user. So let's do pattern users map dot I think we're actually going to do the same thing, compute if absent. So I'm going to pass in this pattern here, and if this pattern doesn't exist, we're just going to make a new set, and let's see, I'll do, and I actually want to store this in a variable. So let's see, actually what I want to do here, pattern users map is holding a set of strings. Just copy paste this. So this is going to be the users. So this is going to be all the users that access, or that followed this pattern. I don't know how to word that properly, but yeah, basically this is all the users that visited the websites in this pattern. Okay, and we want to add our user up here. So boom. So all we did was we created the hash set. If it doesn't exist, we returned it. We returned that hash set, and then we're adding ourself to that pattern. Okay, and then we want to check if users.size is greater than our max score. So I haven't created this variable yet. I'm gonna do that right now. So let's create that right here. Int max score equals 0. So if our users.size is greater than our max score, then this means that our max score should be set to users.size. And we want to actually store this pattern. So let's just say string result. So this is the thing that we're going to return. And I'm just going to set this to the empty string. You can set it to null if you want, doesn't matter. Result equals, because, okay, we've just found so users.size, because this size is greater than our max score, we just found a pattern that is, well, that has our greatest score. So we're going to set our max score to that size of we're going to set our max score to the number of users that access this pattern, and then we're going to set our result to the pattern, because this is the thing that we want to return. Okay, and otherwise, if users.size equals the pattern, or sorry, if it equals the max score, then we want to set our result to either, we want to set, so if this pattern is alphabetically or lexicographically less than our current pattern, our current result, then we need to set it to that pattern. So for example, we need to do result dot compare to pattern. So if this is less than or equal to 0, so if this compare to will return -1 if result is less than pattern when it's comparing them like alphabetically, or it'll return 0 if they're equal. So if result is less than this pattern or less than or equal to this pattern in terms of like being in alphabetical order, then we'll just set result to itself. And if it's greater than, so if like say compare to returns 1, then that means that pattern is lexicographically or alphabetically less than our current result. So we're going to just set pattern to our result. Okay. And I think, are we pretty much done? I think I just need to, yeah, so we have our result now, and now we just need to actually convert this to a list of integers. Or sorry, a list of strings. So we're gonna just do return.result.split because result is a string, so we're just gonna split it by our delimiter that we used earlier, which was a colon. And we're gonna, so this will give me an array of strings, but I need a list of strings. So what I'm gonna do is just do arrays.as lists, and that'll change it to a list of strings. So let's just run it. All right, where did I mess up? Variable k 32. Oh, so just this needs to be something different. So I changed k to key here. It doesn't matter. All right, run the example test cases. Make sure nothing's wrong. Cool. Submit it. All right, so that's how you do this problem in one. So there's a lot of different ways you could do this, and I feel like this is like one of the shorter ways because it's only about 45 lines of code, but the time complexity isn't very great. And what I think something I want to point out is like if you really wanted to like optimize this, so I don't think there's any way around this like n cubed thing that we're doing here, but you could definitely optimize a lot of the stuff that's going on inside of here. And like the big pain point would be that we're dealing with strings, because get value here, this is the name of the websites. But what if we just converted our websites into integers, and then we wouldn't have so much overhead when we're comparing strings and like concatenating strings and stuff. But if we converted the websites to integers and or IDs, and those IDs represented the order of which if those IDs represented their alphabetical order on top of that, I feel like that would really clean up a lot of the time complexity that's going on inside of this. Because like we're wasting time here with the concatenation, we're wasting a lot of time with where is it? This compute if absent. So when it's taking in a pattern, it's going to be like checking, like the hash map itself is going to have to check if the string is actually equal to some other string in the when it's like hashing it out, it's going to have to basically operate on a string instead of like an integer and do the comparisons with a string. And then where else are we messing up? Let's see, compare to. Oh yeah, so this compare to right here, that's going to be another like O of S operation where like S is the longest length of a string. So yeah, so this would be like O of S, this would be O of S, and yeah, it's just killing our time in here. If we were just like, so we would have to like do some extra bookkeeping where we convert our usernames and our websites to integers, and then we would at the very end we would want to like convert back our integers to strings so that we could return the right thing. But I just wanted to point that out. I just thought that was like something useful. But anyway, yeah, if you like the video, you can give it a thumbs up, and yeah, you can subscribe. Cool, bye.